In this example, we're going to look at integrating with respect to y as opposed to x. And this is useful when you have x as a function of y rather than y as a function of x. And you can't easily manipulate either. You can't manipulate the equation to make it a function of x, as we can see in this case. So we're asked to find the area between x equals y cubed minus 4y, the y-axis, and the lines y equals 0 and y equals 4. So the first thing to notice is that we really can't solve this equation for y in terms of x. So we have to just kind of deal with what we're given. So we're going to have to graph this function. And I mean, I guess there's a couple ways to approach this. One is so by symmetry, you could just replace all the x's with y's and the y's with x's. You can replace the y-axis with the x-axis and the lines y equals 0 and y equals 4 with x equals 0 and x equals 4. And if you do that, you've essentially just, your area is going to be exactly the same, and the answer is going to be the same. So that's completely something that you're welcome to do if it makes it easier. I'm going to do this example as though we couldn't do that, just to give you some experience graphing different types of curves that are not functions of x. So the first thing to do is just maybe factor this and write this as y times y squared minus 4, which is y times y plus 2, y minus 2. And then we see that it can be confusing, I think, for some people when you're graphing these things, but these are obviously y-intercepts. So there's a y-intercept at 0, at 2, and negative 2. And we also see that it's a cubic function, so it should have that sort of wavy graph. But the question is sort of the direction it's going in. So maybe plug in a number like 1 for y. If you plug 1 in for y, you get 1 cubed minus 4, which is negative 3, actually. So that means that when y is 1, x is negative 3. And so that tells me that this graph's doing, and then when you plug in negative 1, you get positive 3. So that tells me that this is a cubic function that's doing this. And so we're asked to find the area between the curve, the y-axis, and the lines y equals 0, which is the x-axis, and y equals 4. So the thing to keep in mind is that the area, when it says find the area between, it's assuming that you've actually trapped all the area. So this area has been completely trapped by those regions, right? The curve, the y-axis, and the region are trapping that area. And also the two lines, the x-axis and the line y equals 4, and the curve are trapping this area, which will go all the way out to here. So that is the area we want to compute. So what can you do? Well, you can set up an integral that's going to get you this area here. We'll put an a in here, area a. So that integral is going to go from y equals 0 to y equals 2. I'm going to put the y's in just to emphasize it. Y equals 0 to y equals 2. And it's with respect to the curve y cubed minus 4y dy. Now careful, if you do that integral, that's actually going to return a negative value. Just like when we're integrating with respect to x, if your curve is below the x-axis, then that area will be counted negatively by the integral. Same thing here, it's just that the curve's not below the y-axis, it's to the left of the y-axis. So anytime the curve's to the left of the y-axis, that area is going to be counted as negative, so we had to fix that with a negative here. And then we're just going to continue on and add it to the area from 2 to 3. So again, that's y goes from 2 to y equals 3 under the same curve. And that should give you that area completely as a positive number. So that's one option. Like I said, if you just change all the x's to y's and y's to x's, this problem, that answer would turn out exactly the same. The other thing you could do is you could just integrate from 0, y equals 0 to y equals 4, and just take the absolute value of the curve. It'll reflect all those negative y values and make them, negative x values this time, and make them positive. So So these are both acceptable answers.